Hey, let's get the show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 1108. Hopefully, you guys are doing okay. I have like my 3 laptops set up here again. Well, a bunch of tablets and stuff. So I figured for today, it would be nice to quick change of plan here. Got to be on your toes. But to maybe not start anything new, maybe just maybe talk a little bit about the test, do a little review, nothing structured, just kind of going with the flow here. So I thought I would do that. I had an office hours with a student who asked me about linear programming on the computer. So I figured I'd do another example of that and maybe talk a little bit more about the test. So I think doing that for today would be nice, instead of starting a whole new thing where we're not even going to get very far in it. It just doesn't seem to make a lot of sense to me. Okay, so that being said, let's actually just jump into it here. All right, so here's a problem that I made up. Okay, so let's say I put this on a test, and I'll talk about the test a little bit more in a bit. But I put this problem on a test. You'll notice that there are 3 variables here, x1, x2, x3. I might have x, y, z instead or something like that. So yeah, you'd have to draw this in 3 dimensions, which, I mean, even for me, that's going to take forever, right? So you don't want to use the graphical approach. You're definitely going to want to be able to solve this using something like some software, okay? So what I want to do is I want to go through solving this with Excel. And chances are in the test, I'm not going to have you pulling up Python and coding stuff and doing that. So what I'd probably do, what I'm thinking, an Excel file, I'd ask you to create an Excel file and upload an Excel file. I don't think that should take too long. But in terms of the Python part, what I'd probably do is just I would give you the code, give you the script that you would run to solve one, but then I would have you just modify the script. So you would type in here what the changes that you would make to this code to solve this problem, right? So I thought we would do that as well. So it's kind of you had this problem to solve. You go and Google someone solving a linear programming problem. You see that this is the code that they used. How would you modify it to solve your problem, which is a useful skill to have. That's it's 80% of programming right there, just looking up what other people did and just changing. Yeah, I know. So I figured we would do that. So this is the problem here, and I guess you could take a screenshot or something of that. But I will probably switch to the other guy because I'm not going to use Excel on the iPad. That's just not, yeah, it's, so that's what we're going to do. Then maybe talk a bit about some other problems, and someone's trying to get in here. Instead, maybe. Okay. So here was the basic setup for our Excel file. As you can see, there's not much going on here. So there's no code or anything like this. This is just literally me I typed up these words. So you can have a little Excel file where you have that structure pre-typed if you want. And then when you see a problem on the test, you just go and you fill things in. So what you would have to remember is where you would fill things in. So you don't mess with this table up here, right, where your variables are going to be. These cells here are going to be important, but you don't have to put the code in there. This is going to be important. You're going to have to put code in here. So for these, optimal value will show up here. and optimal objective will show up here. We had here 1, 2, 3, 4 constraints. So these cells here, you're going to have to fill stuff in. Wanted the lighter one. And here, you're going to have to fill stuff in. And here, you're going to have to fill stuff in. So this means code needs to be, I mean, calling it code in Excel is kind of a stretch, but whatever. Might as well pump our ego and let us think that we're typing code. Code needs to be filled in here. Or not filled in here, filled in boxes of this color above. Okay, so that's going to be the basic structure. And you are going to basically fill in code here, and code here. And that's going to solve the problem. So maybe I can copy and paste. Not sure if a picture would paste in here. No, didn't. Never mind. So the problem was we wanted to maximize something, and I will tell you what that thing is here. So it's equal. So remember, you have to press equals. And the actual objective was 20x1 plus 10x2 plus 15x3. So that's what I'm going to do. 20 times x1, so I click on that cell, plus 10 times x2 plus 15 times x3. Enter. And so maybe I should call this x1, x2, x3, right? And that's what you enter there, right? Then here, you're going to fill in the constraints. Now, the first constraint, which if you didn't screenshot it, I'll of course upload the notes and you'll be able to see it, was 3x1 plus 2x2 plus 5x3, 3 times x1, oh, sorry, see, I forgot to press equal, equals 3 times x1 plus 2 times x2 plus 5 times x3. Enter. And that is supposed to be less than or equal to 55. Then I move on to the second one, equals 2 times x1 plus 1 times x2 plus 1 times x3. And that is supposed to be less than or equal to 26. And now I have equals x1 plus x2 plus 3x3 I want that to be less than or equal to 30. Then we have 5x1 equals 5x1 plus 2x2 plus 4x3. I want that to be less than or equal to 57. And all variables non-negative. Right, so you could put that as an extra constraint, but it's not necessary based on what I told you guys last time. So that's essentially the setup. That's what you would type into the Excel file. And then you're going to go to your solver, which is under the data tab. Which reminds me, for any of you using a Mac, apparently there's no like file thing. So there should be somewhere up here that says tools or something like that. And that's where you would go tools and options and find the Excel solver add-in. So here, again, just to be safe, I always reset it just to make sure that nothing is filled in that I don't want filled in. I know I want to maximize that selected. What do I maximize? I want to maximize this expression here by changing which variables? These variables here. Enter. So I can click this and highlight the cells, or I can literally click on this and click on the cells, drag and drop. And now we go to our constraints and I add my constraints. What are my constraints? I want this to be less than or equal to that, add. I want this to be less than or equal to that, add. I want this to be less than or equal to that, add. I want this to be less than or equal to that, add. Okay, so once I'm adding everything I want, I can cancel. I'm out. Now there are the 4 right there. You can see the cells also make sense that it's B14 less than or equal to D14, for example. So this is column B, row 14. That's this guy. I want that less than or equal to column D, row 14. And so these guys all make sense. The numbers here should match up. 14 goes with 14 clearly because I'm going along a row. And I'm matching up things in the B column, making sure that they're less than or equal to things in the D column. So you can like just eyeball it to make sure. Here, I can make sure I can check any unconstrained variables are non-negative. That will guarantee that my x1, x2, x3 is considered to be greater than or equal to 0 without me having to specifically say that. And then I set this to simplex and solve. And yeah, that's the idea. And so, yeah, these are the optimal values, 1.8, 20.8, 1.6, and the maximum I can achieve is 268. That's it. And what you would do is you would save this file and you would upload it to whatever. And I'll probably give you some naming convention to save it. So save it as your name, test 1, problem blah, and you would upload it to Gradescope. Any questions on any of that?
Yeah, Professor, do we need to use both methods to do the questions?
Yeah, but not really, almost. So for Excel, so you're going to need to know how to do it by hand. That's never going to be a test problem to itself, right? Then I'm going to give you a problem that you can't do by hand because it has 3 variables, maybe even 4 variables and a few constraints. And I will ask you to do that in Excel and maybe just modify a Python code to actually solve it. So as for the Python itself, I wouldn't have you guys pulling up Python because you're pulling up Gradescope and then you're pulling up Cell. To pull up a 3rd program is kind of overkill. I don't want to like do that. So I would just like give you the Python script and say, okay, here's the script that could solve this, but there's some wrong stuff filled in here. Make sure you go through and you fix the wrong stuff. You know what I mean? So it's just to see whether you can read the code, understand it enough to know what you should be filling in the code, right? And
so we don't need to open the Python to do
you won't need to open the Python. Okay. You will need to open Excel. Okay. And the nice thing about, well, never mind then. Originally, I was thinking of having you guys do both, but I figured that I thought that would be overkill. That wouldn't be nice. I was going to say the nice thing would be if you used both, you could actually check yourself that you got the same answer both times. But yeah, that's kind of how the Excel would go. I would be okay if you pre-typed like the structure into an Excel file and just have it ready to go. But you're not, of course, going to know what code you should be typing into it until I give you the problem on the test. But yeah, that's how you do it. Now, as for, so maybe I should write down that that was the answer.
But this will not be on the test on Sunday, right? The coding or Excel.
Oh no, this will be.
Oh,
So
well.
Yeah, so the test will be covering financial math and linear programming, essentially. Those are the two main topics. So I'm going to ask you a bunch of word problems about finances, like, oh, I want to buy a car, you know, and I know I can pay this much per month. Like, what is and if these are the loan terms, what is the maximum car price I have to get, right? So I'll ask a question like that, and you would do the calculations. And, you know, so I'll ask a bunch like that, where I'm asking about amortization, sinking funds, like a compound interest problem, compounded continuously problem, where it's just like, you know, the formulas, you read the word problem, you plug them in. I'll give you a linear programming example where there's like just a word problem where you set up and solve it graphically by hand. And then I'll give you a problem like this, where it's like, okay, here's another linear programming example. Don't even worry about the word problem that it comes from. I'm just going to tell you, maximize this with these constraints, or minimize this with these constraints, right? It's relevant somehow. You don't need to know, right? Like you're the calculation monkey, the Excel monkey that they have, that they keep in the basement, and they're just like, solve this. We need to solve. Like, you don't know. Okay, you just solve it. Okay, so that's what it's going to be like. You're going to solve it in Excel, and then you are going to modify Python code to solve the same thing.
Okay.
Yeah, so I think like that is basically the structure of the test, and maybe I'll write that down in a little bit. So I'm thinking it'll be an hour and 15-ish minutes, and I'll give you an additional 15 minutes to upload stuff. So it's going to be, you go in Gradescope, and I know I still need to post like an example. I'll type it up after my classes today. You'll go into Gradescope, you'll see the question, and then there'll be a button that says upload. So pretty much you're going to see the question, you're going to solve it on paper, you're going to like take a picture, and then you're going to upload it. And then you just do that. And there'll be about 6 or 7 problems or something like that, and including the coding thing. And then you upload your Excel file, and then that's it. Yeah. Now, as far as it goes, so let me actually write down that this was the answer. So, solution.
Professor,
Yeah.
I have a question about the tester.
Yes.
So like, what time do we have to take it?
I believe it's at 9.
Okay.
I believe it's at 9 a.m.
Is it going to be proctored over Zoom? So we all.
No, you log in and you take it. We're doing
Oh.
the honor. We're doing the honor code. Don't let me down. It can actually be easy, even if I'm not watching you. It turns out that it's easy to tell when people are cheating. Like I caught a bunch of people cheating last semester, and I could tell them who they cheated with, and you're like, how did you know he wasn't even watching it? Like, don't cheat. It's just not. Okay, so yeah, and the max P was 268. So now, let's see here. Okay, so I wrote down the answer here. And all right, now what you would also be given is just like a script like this. So assuming that we want to solve the same problem, how would you actually go about solving such a problem? Well, you should be able to know to go in, all right, what's going on here? Okay, so we're creating a model. It has this flaw. Don't know what the hell that is, so I'll ignore it because I'm a programmer. That's what we do. I just go to the things that I know I want to change. Create variables. Oh, I definitely want to be able to control my variables. So here it looks like this person is adding 2 variables. problem I want to solve has 3 variables. It probably makes sense to add another line like this. So I'm going to just copy here, paste that. Of course, indentation is very important, especially with a language like C++. And then I would, which, does anyone use that anymore? I don't know. So, right. So I know that I would have to add that line, right? So that's something that you would do. All right, so now I have the 3 variables. The lower bounds are all equal to 0, which is, I was given that they're greater than or equal to 0. So, okay, so the variables are now set up. All right, now moving down, set objective. Ooh, that seems like it would be important. What is the objective they have here? That's not the one I want, so I'm going to change that. 20 times x1 plus 10 times x2 plus 15 times x3. And whoops, don't want to minimize that, better change that. I want to maximize. All right, so we're good. All right, constraints. I definitely want to talk about constraints. There's only 1 constraint here. No, we had like 4, didn't we? So then I would go here and I would just copy that. And obviously I'm going to want to fix all of these constraints. So my first constraint, according to this problem, is going to be 3 times x1 plus 2 times x2 plus 5 times x3 less than or equal to 55. That's constraint number 1. Okay, now move to constraint number 2, which I mean, I probably wouldn't give you like 4 constraints because if you know how to do like 2 of them, I'll know you know how to do it. Like there's no reason to give you 4, but I just chose a very robust example because I'm the one doing it. Okay, so 2x1 plus x2 plus x3, I want that to be less than or equal to 26.
If the code isn't exactly as you have it, like if the spaces are a little bit off or like we miss
spacing in general when you're typing is not going to matter except with indentation. So so it's actually not a coincidence that the try here is a little bit farther to the left than where everything else starts. Like indentation is going to be important. But other than that, if you were to type like a space between the plus symbol and the terms, it's not going to matter. And I wouldn't downgrade you on that. I would just check, did you fill these lines in correctly? Did you change the minimize to maximize? Did you enter the right thing? Did you have the 3 variables instead of 2 of them? So things like that is what I'm looking for.
No way.
Huh? You understand? Okay. So x1 plus x2. So the thing is, like I said, I'm going to give you the script. So the indentation and all that is not something you'd have to worry about. If you were a programmer, you would have to worry about it, but you won't have to worry about it for me. You're just going to take the script I give you and you're going to modify it. So you're just going to change certain parts in it, like exactly like I'm doing right now. In fact, this is. Yeah, I'm a big fan of teaching by example. So a lot of times students might be like, well, how much work do I have to show for you to give me full credit? Or what do I have to, exactly how much I show in class? Like I show you exactly what I want you to do, right? So yeah. And that would be it. That would be, you're done now. Like everything else is going to run. Like none of this other stuff you control. It's all about printing out the solution, right? So there's some stuff here about printing out the solutions and like a website that you can find out about Garobi and this model. And it's yeah. And then, oh, tell me there's an error. Like none of that you would change, right? The only thing that you would change is you want to make sure that you have all the variables you need. You have the right objective, you have the right constraints, pretty much. Yeah. Okay. Okay, going back. Now let's actually talk about maybe I should share that other stuff because I think some people were asking me some of those questions as well. So maybe I should share a little bit about that. Okay, so now you're seeing my browser. Okay, so the class website, obviously very important to know. If you want to know the kind of problems I would ask, you'll notice that they're actually going to be very straightforward compared to the examples that I do in class. So there's some test one reviews, which I told you should like ignore matrices. So test one practice, you could do that. And here's a practice test one. So a practice test one, this was again for a previous semester, so it's not exactly. Like problem 6, 7, 8, you would totally ignore because those have to do with linear algebra. But like here are examples, you know, like determine the simple interest on this after 20 years with this APR. I would just ask you that problem. You write it, you tell me, oh, I'm going to use this formula, plug in the numbers, tell me the answer. Lindsay bought a new car for $29,000. She paid 20% down payment, and the remaining balance she borrowed at 4.4% APR. Assuming she made monthly payments, what is the cost of the car, right? So essentially, that's like you figuring out a present value formula. Here, yeah. So this person starts an IRA, saving for retirement. They deposit $400 a month, so that's your payment. That's the average interest rate. How much money will this save at 65, right? So that's like you finding a future value. So things of that sort. This you can ignore. I think that's a Venn diagram problem. If we started sets, I would have given you a problem like that, but you wouldn't need it. And here's a linear programming problem, right? You find $19,000 in a dumpster, you want to invest it because, you know, right? And then I give you a bunch of bonds and stocks that you can invest it in, and you're just going to figure out how you want to invest it and what the max income is going to be, right? So I'll ask you questions like that. And then I'll ask you a question like, it's not going to be like this, but like I said, I'll just give you a linear programming problem and say, do this in Excel. So it's like, you know, 1, 2, 3, 4, 5 with 2 parts, something like that.
Where can we find this test?
Oh, it's on the class website.
Okay.
So if you go to the class website, there's test reviews, right? So and like I said, these were for the previous class, so it's not everything is completely relevant, but a lot of it still is. And you can go there, and there are practice problems, not including matrices or linear programming, and there are practice problems including matrices and linear programming. So you can click on that, and they're just like a bunch of problems. And it has sets, which of course you're going to ignore too. It has just a bunch of problems for you to just try. And it also has the answers at the end. So the problems that I would ask you in terms of word problems or finance problems, they're at this level of difficulty. So you can try it and you can check your answers. And then if you want to practice some linear programming, you probably go over here. Yeah, and there's a linear programming problem. Here's a linear programming problem. I think it's similar to the plain sharing food thing that we did at the end. And again, I gave you answers at the end. But of course, you'd ignore anything that has to do with matrices. I don't remember where I saved these files. If I can find them, I'll find them and just like delete the irrelevant problems. But hopefully you're paying attention enough to know that Jhevon never drew anything like that. So probably I can just ignore it. Sometimes it's funny. Students ask me, do we need to know this? Have you ever seen me write anything like that in class, ever? Yeah, and then you could do that. So your test would be smaller, 6-ish problems, something like that. Yeah, as far as level of difficulty is concerned, this is the level of difficulty. You can go and you can see. And in addition to that is going to be a problem like the one I did with you earlier in this class, where I'm just gonna give you a linear programming problem, solve this in Excel, and modify this Python code to solve the same problem. And that's going to be that. Yeah. Last time I taught this, it was not in Gradescope, so I don't really have like a template of a Gradescope test for this class that I could show you guys, but the Gradescope part isn't going to be not the craziest thing, I think. Especially after I give you guys like a practice test, I think it would be pretty intuitive for how to use it. But yeah, that's
Professor, so we need to write down all the steps and take a picture.
Yeah, I expect you to fully write down your steps.
Okay, thank you.
And furthermore, if you're like, well, how much steps do you actually want us to write out? Well, I can answer that pretty easily without even doing anything. You see how many steps I show when I'm doing a problem? That's how many steps I want you to show. So there was a problem. Like, oh, if you ask us a linear programming problem, how much work do you want us to show? I want you to show everything I did. The only thing I would probably say is that the setup is not so important to show, like this part here. But of course, you definitely need to write, down the linear program problem that you read the word problem and you understand it. You need to be able to write down the problem that says this is the problem I'm solving. Then you need to show the geometric picture. Then you need to find your corner points. Here you don't have to write as much, because if you have like a calculator that can solve a system of equations, I'm okay with you just stating the system and then telling me the solution. So you could just say, oh, I know I want to solve 2x plus 6y equals 30 and intersect that with 4x plus 2y equals 20. And I know that the solution is going to be 3, 4 by TI 89 or whatever. And you can write that, and I'd be fine with it. Then I would need to see that you actually wrote down a table, so you know that, oh, I need to check the corner points. I need to be able to see that you would know that you need to check these 3 things. And then I'm looking for you to be able to state your answer, right? So in terms of how you're going to write it out, you'd pretty much write it out how I do. This first part where you're kind of just setting it up, trying to understand the problem, just putting all the data in the table so you don't get lost in the word problem. You don't have to show that. It would be helpful though, because in terms of like partial credit. So maybe if you set up the slightly wrong system here, I can at least see that your reasoning for setting up that system was something on point, as opposed to if you didn't write that, then I would, I would be able to give you 0 credit for this section here, because like, I don't know where you got that problem from. So yeah, you kind of want to write as much as I do in class, but in general, just write enough for me to know that you know kind of what you're doing, you know where to look to get what numbers, you know what formula to use, you know a clear path to the solution. Okay, I read this word problem, what needs to happen? I need to be able to set up a linear programming problem. I need to be able to draw it. I need to find the corner points. I need to test the corner points. Then I need to state the answer. Like me reading your work it should be clear to me that you know those were the steps. You know what I mean? So it's not like, you know, you didn't even write down the linear programming problem. You have a picture and it's wrong. Somehow you got the right answers. Like, what? Like, no, you didn't, like something is off here. You know, and you didn't even show me the table where you tested. How do you know that that was the maximum? Like, what were you testing it against? Like, right? So just make sure that there are no gaps in your work where I can read through your problem. I can clearly see where your line of thought was going, right? So that's going to be important. In terms of specifically setting it out some specific way, not really. I don't particularly care as long as you write legibly and you write in a way that I can follow you fairly easy. So for those of you who like to write problems where it's like, you do one part of the problem over here, then you do another part over here in the top right corner, and then you do another part on the other side of the page in the bottom left corner, and then I have to I have to be doing like a detective show where we're pinning the webs in the board, trying to figure out where the serial killer is. Like, okay, we picked up this. Like, no, I shouldn't have to do that to read your solution, right? As long as I can just read it and okay, I'm following the steps and I can see it's all right there, I'm good. And there are no gaps. Like I don't ever wonder, well, where did that number come from? How did this person get this number right here? And we'll be good, you know. So yeah, so I mean, if you have this table with, oh, I'm testing 2, 6, 3, 4, 9, 2, and you never actually show me that you actually solved this, I'm gonna be like, where did 9, 2 come from? You know what I mean? Like if you never actually even mentioned, oh, the 9, 2 came from me solving this system, right? So I expect you to just like, let me know where everything comes from, and so on, right? So you'll notice like in any of our examples, I never just like tell you the answer. I always like write it out. I always, you know, even back when we were doing simple interest, you know, I would say, you know, I would write out, well, these are all, So you can see that even when I'm doing the simple interest problems or these simpler problems, there's a clear like path. You can kind of see where my thinking is. Clearly, I've identified the relevant numbers. I've also identified the relevant formula, and then I plugged the relevant numbers into the relevant formula, and I got an answer, right? It's not like I just said, oh, the answer is 1099, and I used one of the interest formulas, you know? So like by one of the interest formulas in class, the answer is 1099. To me, that's not a fully written out solution, right? Here I can see what you're thinking, right? So I can see, okay, the person knows what numbers are relevant. They know the relevant formula. They plug the numbers into the right formula, and that's how they got their answer. I can clearly see step by step where this person was going. And not just because this person was me, but if this person were someone else, I would still know where they were going by reading this. You get the idea? So yeah, you want to know how much you have to write out? Look back at our notes. I write out how much I want you to write out, essentially. These are just some other stuff. Yeah. So that being said, I wrote out a test bank of a bunch of problems that I would want to ask on the first test, but I haven't actually put it in a structure yet, so I can't say for sure. But so let me just put in notes here, test 1. Rough, is it March 14th? It was 14th, right? At 9 a.m. Roughly 1 hour, 15 minutes long, plus 15 minutes upload time. So that is time to upload your scans, which I would recommend you upload them as you go, as well as time to upload the Excel file at the end. There'll be an upload button where you click and you can upload these. By the way, you can log into Gradescope from multiple sessions. So you can have a session on your screen and you can have a session on your phone where you can literally just, every time you want to upload something, just take it on your phone and upload it directly from your phone. but you can just use your computer to read the question off. That might be the most time efficient. I'm thinking 6 to 7 problems. Covering financial math and linear programming. By hand, linear programming by Excel, and linear programming by modifying Python script. So this is going to be like one problem here, right? Just a word problem. This is going to be like one problem with 2 parts, one problem, 2 parts. Right, so the one I asked you about in Excel, it will be exactly the same one that you would modify the Python script to solve. Like I wouldn't give you a different problem. And so here they're going to be, 4 to 5 problems. Right, covering the kinds of interest. So like a compound interest problem, an amortization problem, a sinking fund problem, things of that sort, where you're using all the formulas. So it might also just be, there might also be a couple questions where it uses the same formula, but you're actually looking for different things. So for example, remember the sinking fund formula is a formula that connects your payments to some future value, right? I might ask a problem where the goal is for you to find the future value, but I may also ask a problem where the goal is for you to find the payments. And I might ask 2 such problems. So there might be 2 problems where you have to use the sinking fund. You'd have to recognize you'd have to use the sinking fund. And at the same time, you need to know which part of the sinking fund do you need to solve for. Am I looking for the payments part, or am I looking for the future value part? Right, so that's where the 4 to 5 problems might come in. As far as level of difficulty is concerned, go to the class website, look up some of the old problems I have. That's how they're going to look. You're not really going to find anything on Python and Excel because that's something that I did for this semester. But you have the example in here, and you would have the video of me solving it. So you would know, yeah. So it'll be something like this. I would give you this problem, and it'll be 2 parts like this, A and B. Solve the LP. So test type problem. Test problem type. That's it.
Professor,
Yes.
I have a question. In the section of finance math, do we need to write how we choose which formula? Do I need to write down those kind of things?
Not completely sure what you're asking, but maybe I'll do this. I might be able to do something. Hold on.
I mean,
where are we? I don't know. Did I have those? I
think you meant like, do we need to write down why we chose like a certain formula?
No.
For the, okay. If that's.
I don't remember if I have it. Oh yeah, I did. Yeah, so this is good. So I gave some sample tests also, and I literally wrote out what I wrote out for the solution that semester. So, so this was a test that was given on paper. And so here's an example of a problem. So this is actually a test. I gave this back in 2019. Yeah, I'm a stickler for memes. Anyway, so here was the problem. Suppose you wish to borrow $400 for 2 weeks. What amount of interest would you pay? And I'm like, using this formula, blah, 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 plug in the right numbers. That's the APR. Or, oh, here is a school building was a new school building recently built in your area. The entire cost of the project was $22 million. The city had a 30-year loan for the problem with a 2.8 APR. And then I just like determine the total amount of payments for each family. And then I was like, okay, using this formula. And obviously here, this is the amortization formula because we're paying down a debt. We were told that they have a loan and they're trying to figure out what would the payment be to pay off the loan, right? So it's like, well, the payments for the loan would be $90,000 every month or whatever, but that's split among 23,000 families. So each family would have to contribute $50 in their taxes. But yeah, you'll see how I write these problems down. In 8 years, it will take $200,000 to attend college for 4 years. You have a substantial amount of cash. How much should you put aside now in an account earning 12% compounded monthly in order to have $200,000 in an account 8 years from now? And I'm just like, using this formula, here's me plugging in the numbers, here's the answer. Yeah, using this formula, here's me plugging in the numbers, here's the answer. You see, there's like a logic to it, there's like a structure to it. Here was a problem where there was a linear programming problem so you can see here, I wrote down the linear programming problem. I drew the picture. I found the intersection. So it's clear where this number came from, the 116 and the 29. I tested it in the table and then I made my conclusion. You can like see me writing it out here. So for like a linear programming problem, like something like this is what I would expect you to write out. Matrices is not relevant for you guys. Ignore. I can do this all day. It's done. And I gave them a formula sheet where here's the single point formula. So yeah, so all this is on the class webpage. If you scroll all the way down, you can go to test 1 blank. You can literally fill in the solutions for each of these problems. All of the relevant problems, of course, in this test, you would ignore problem 3. You would also ignore problem 7. Problem 8, you would ignore as well. Problem 9, you would ignore as well. And then you would go back and you would check, what are the answers? Did I get them right? Did I write out as much as Jhevon would probably think is reasonable, right? So yeah. Yeah, so really, I mean, there's stuff here. You'll have to work a little bit in the sense that you might have to just ignore some stuff that we just never spoke about. But in terms of what needs to be done, the level of difficulty, how you need to write out your answers, that's all there online and during class. So yeah, that's that. Anyway, I have another one of your classes pretty soon in like 5 minutes, so I'm going to let you guys go. I teach today until 1-ish. I want to say 1. So at some point after that, I'll just type a little thing in Gradescope and send it out to you guys. It's not meant to be practice. It's meant for you to get used to Gradescope and what it would feel like to actually log in, read a problem, upload an answer, that kind of thing. Yeah, we'll stop there. Yeah, nothing else to say. I guess that's it. Thanks for your attention. Hopefully that was helpful. I will see you guys in the next one. Ciao.